For tonight's homework, we're going to do some notes related to conversions. So make sure you have your packet open to page 12. You can use unit rates such as 3 feet per yard to convert measurements. The following relationships may be helpful in our next classwork problems. We're talking about this whole big table right here. So make sure you kind of keep this as a reference moving into problems for tomorrow. You can also use proportions to convert measurements. So if we know unit rates such as 3 feet per 1 yard, that's a unit rate because it has a 1 on the bottom, we can convert measurements. So for example, I could find out how many feet are in 5 yards. I can scale this up by 5, and I would find that there's 15 feet in 1 yard. So now let's look at some examples of problems. And again, you can use lots of different strategies to solve these conversion problems, but we really want to focus on thinking about proportions, unit rates, unit tables, equivalent ratios, really all the strategies we've been doing from comparing and scaling. So in problem A, Kate walks 5 miles in 2 hours at a steady pace. How far can she walk in 1 hour and 15 minutes? Well, the strategy we're going to look at here is setting up and solving a proportion with a scale factor. And again, we did this same strategy right up here above. So if she walks 5 miles in 2 hours, I want to know how many miles she'll walk in 1 hour and 15 minutes. Well, one thing to think about though is I can't just say 1 hour is 1.15 hours, right? 1 hour and 15 minutes is a specific number of hours. So I need to think about how 15 minutes out of 60 minutes is actually a quarter of an hour. So 1 hour and 15 minutes is 1 1/4 or 1.25 hours. So make sure I have the correct value over here so I know how to scale it. So now I can go ahead and find a scale factor. So I want to find 2 times what would give me 1.25. So again, to find that number, I can take 1.25 and divide by 2. And when I do that, I'm going to get 0.625 or 625 thousandths. So I'm going to go also multiply on the top by 0.625. And I'm going to get 3.125 miles. It's important to realize here, if I go 5 miles in 2 hours, if I'm only walking for 1 hour and 15 minutes, I wouldn't expect to walk quite as far. So make sure you're thinking about that carefully. So again, my final answer here is going to be 3.125 miles. You could also represent that with a fraction. I'll let you think about what that fraction would be. In problem B, there are 276 calories in 6 ounces of chicken. So how many calories are in 1 pound of chicken? Well, I have to know a few different things here. I'm going to focus on this strategy called finding a unit rate and then scaling up with a scale factor. And you'll notice here I'm talking about ounces and pounds. So I need to make sure that I'm comparing the same thing. I'm going to choose to make my pound into ounces. And so if you look at that table at the top, you'll find that there's 16 ounces in 1 pound. So if there are 276 calories in 6 ounces of chicken, I'm going to go ahead and think about, first of all, what would the unit rate be? So how many calories are there in 1 ounce of chicken? So if I go ahead and multiply here, I know that 6 divided by 6, or 6 times 1/6, would give me 1. So 276 times 1/6 would give me 46. So again, notice this here is a unit rate. This is the number of calories per ounce. And now I can scale it back up to 16 ounces. So 1 times 16 would give me 16, and 46 times 16 would give me 736 calories. So that's my final answer, 736 calories. We've got 2 problems left. For C, 1 cup of whole milk has 8 grams of fat. How many grams of fat are in a gallon of whole milk? I'm noticing that there's cups and gallons mentioned here in this problem, and so I'm going to need to think about a conversion. For example, 1 gallon, based on the table up above, has 16 cups. It's kind of funny that way, that 1 pound is 16 ounces and 1 gallon is 16 cups, but that's just kind of how it works. So this strategy we're going to use is a rate table. So we're going to use a rate table, find a unit rate, and scale up with a scale factor. So grams of fat, there's 8 grams of fat in 1 cup of milk, and that's actually a unit rate. And so now what I'm going to think about is how many grams of fat are in a gallon of whole milk. And so I'm going to put in 16 cups here, and I'm going to scale that up. So 1 times 16 is 16. 8 times 16 would give me 128. And this last column here is actually just kind of extra in case I wanted to add another value into the table. So in this case, I'm looking for this value right here. 128 grams of fat are in 1 gallon of whole milk. Now for problem D, you're going to choose your own strategy and solve the problem below. So take a moment and see how you can think through that problem. Again, you might want to use a proportion, you might want to use a unit rate. Think about what makes sense to you. Are you ready to check your answer? So Nathan can use 2/3 of a tank of gas to cut 3 lawns. I'm going to use the letters T and L for tanks and lawns. So if he has a full tank of gas, so 1 whole tank, I could also say 3/3 of a tank, I want to know how many lawns he can mow. So I'm going to go ahead and find this scale factor. So 2/3 times what would make 1? This scale factor is going to be 3/2. So times 3/2. So 3 times 3/2 would give me 9/2, which is the same as 4.5. So he can cut 4.5 lawns with 1 full tank of gas.